to All Things Pharmacy. Today we're going to be discussing azo compounds. We're going to discuss what is an azo compound, the properties of azo compounds, how azo derivatives are synthesized, and the ways in which the azo derivatives are synthesized. Azo compounds have a general formula of two nitrogens that are double bonded to each other, and each of those nitrogen is bonded to an R group. The R group can either be aryl or alkyl. Aryl meaning aromatic and alkyl meaning it's not aromatic. Azo compounds can also be defined as derivatives of diazine. Diazine is a molecule where instead of the R groups, there's the hydrogen atoms, and derivatives of diazine, to get azo, you have to substitute the hydrogens with either an alkyl group or an aryl group to get the general chemical formula of azo compounds. So this is where the general chemical formula originates from the formula of diazine. Now we're going to be talking about the properties of an azo compound. An azo compound, if both of the R's are substituted by an aryl group, the azo compound is stable and it's also crystalline. It also shows intense colors like red, yellow. Normally the colors it shows are primary colors. In most cases, the R groups, if they're both aryl, they won't be the same, and so depending on if they're the same or not, the azo derivative can be described as asymmetric or symmetric. Asymmetric is if both of the R groups are different, and symmetric is if both of the R groups are the same or similar. Azo compounds are also used as dyes and are commonly called azo dyes. This is because the other azo compounds, like I said, they display intense colors, and this is why they're used as a dye. They display those colors because of the pi delocalization that is in the aromatic structures. They are also used as acid-base indicators, and they are used as pigments in the textile and paint industry. Now we're going to be talking about the alkyl azo compounds, which are less common, and that's why we're not going to mention a lot of points about them. They can be used commercially as an initiator in free radical polymerizations. Free radical polymerization is when a polymer forms by the successive addition of free radical building blocks, and this is why alkyl azo compounds are not as stable as aryl azo compounds. It's because that they are free radicals that are used in the building blocks, and radicals are very, very reactive. There's also a simple dialkyl azo, and I'm just going to give you an example of maybe how to name one. For example, the diethylene diazine. It's an example of a dialkyl azo. I also just wanted to mention, because aromatic or aryl azo compounds are unstable, it means that they have a risk of being explosive. Now we're going to move on and discuss the synthesis of aromatic azo compounds. We're going to discuss the main way in which these types of compounds are synthesized. One of them is using azo coupling reactions. The word coupling, a coupling reaction is when two aryl groups are joined together by an azo group. Basically, the azo group is the glue that holds the two aryl groups together. The azo coupling reaction can also be called the electrophilic aromatic substitution reaction. The coupling or the joining of the aryl groups to the azo group happens usually at the para position of the orthopara director. The orthopara directors in this case is the aniline and the phenol. In the coupling reaction, the diazonium salt reacts with aniline or phenol. When it reacts with phenol, the azo compound that is formed, you will see that there's an azo group, and then on the right side here there will be a phenol group, and on the other side there will be a benzene ring. And on the phenol group, the azo group is attached to the para position, and another product that is formed besides the azo compound is hydrochloric acid. The diazonium salt used in this case is benzene diazonium chloride. Another example of a coupling reaction is benzene diazonium chloride reacting with aniline, and as you can see in the azo product that is formed, there's an azo group, and on the right of the azo group there's a aniline attached, and it's attached also at a para position, and on the left of the azo group is the benzene ring, and also another product here is hydrochloric acid. This reaction takes place at very cold temperatures because diazonium salts are unstable at room temperature. The next method of synthesizing aromatic azo compounds, and the next method is the oxidation reaction of hydrazines. Hydrazines have the basic structure of nitrogen, hydrogen attached to each other, and then to each of those there will be an aryl group, as you can see, and this compound is reacted with oxygen to give you an azo. I'm going to show you the general formula of this whole reaction. That is a general structure of hydrazine reacting with oxygen and giving you the final azo product, as you can see there, and the other product, which is H2O, water. Azo dyes or aromatic azo compounds can also be prepared by the condensation reaction of nitroaromatics. Nitroaromatics are just compounds whereby there's a most commonly benzene ring, and there will be a nitrite group attached to a benzene ring. There will be condensation of nitroaromatics with anilines, and the product of this will be further reduced, which will result in an aromatic azo compound. Those are the three ways in which aromatic azo compounds can be synthesized. Thank you for watching the video. Please like, subscribe and share. Until next time.